So you see something like this, right? Same as what I have on the screen. Okay, so you can read this, but this will not be there for a long time. What you need to do is that you see this download PDF, click on this, so you can keep a copy. All right, so this online flipbook will be here only for a short while, maybe 1 or 2 weeks. Okay. Yeah, I realize that sending you the flipbook is easier, sending you the link, because some of you are using your iPad to access the class, then it's not possible for you to receive PDF from me. Okay, many of you will have this problem if you're using the iPad. So I decided to send this instead. So far, no problem. So how many of you cannot download this, cannot see this at all? Nobody, right? Okay, good. Okay, so let's start with our lesson. Okay. Now, I will not be going through slowly because most of the things you know already. All right. There are some new things like what Haresh mentioned. Some of the new things you need to learn, like ammeter, voltmeter. Okay, in fact, how to connect them, you need to learn as well because you need to do this in the science lab in school. It could be something like a practical exam also. Okay. So let's start with lesson outline. You must know what is the meaning of current, potential difference, resistance. Okay, you also need to know the units, right? You need to know the units for each of these. Now, you need to draw and interpret circuit diagrams, set up circuits containing electrical sources, switches, lamps, resistors, ammeters, and voltmeters. So you don't see these words previously like voltmeter, ammeter, resistor, but you are familiar with lamps, switches, electrical sources. Okay, and then the next point, recognize that the resistance of a circuit can be varied by arranging resistors in series or in parallel. If you don't know what's resistor, don't worry yet, but it's very similar to the word resist. Okay, something like blocking you, preventing you from doing something. Then explain qualitatively the chemical, heating, and magnetic effects of an electric current. List some application. I think you already know this because electricity can actually be used to break down compounds. Okay, so that is a chemical effect. Heating effect, of course, is to generate heat. We turn on maybe the heater using electricity. Magnetic effect will be the electromagnet. Still remember now? So you actually come across all these already. Okay, and then list some of these applications. Where are they being used? Okay, investigate the effect of varying resistance on the current in the circuit using fixed or variable resistor. This one you also need to know daily example. Like when we talk about resistor, right? How do we use it in our daily life? How many of you have the kind of lighting where you can dim and you can make it bright? How many of you have that? Or maybe in the classroom? Nobody? Nobody, ah? You know, certain classroom, when I was teaching in school, the classroom that I was teaching in, right, they have dimmer. So we can make the room very dim, okay, so romantic, you know, and it's good for the, especially those session, what do we call it? Mindfulness activity. So we turn the lights until it's very low, then we start practicing mindfulness with the students. Okay, so the dimmer actually makes use of this variable resistor. All right, so the variable resistor helps us to even adjust volume. Okay, in the past, when you have those radio, okay, cassette player, you have the dial, right, to turn the volume up and down. They actually make use of the resistor, variable resistor. So we adjust the resistance according to what we want. Okay. So next, talk about current first. How do you define current? Okay, this is being asked. You need to either pick the correct MCQ or you need to actually write down in words definition. Okay, if they ask you to define current, it's defined as the rate of flow of charged particles. So it's actually the measure of amount of charges flowing through any point in the circuit at any unit of time. All right. So we know what is current, but if you are asked to define it, you might have difficulty. All right. Don't just say that is what is flowing inside the circuit. You need to talk about the charges. Okay. So you can talk about the flow of electrons. All right. So one single electron carries a very small charge. Okay. This is 1.6 times 10 to the power 19 coulomb. So let's say you have more charges flowing through the circuit at any point in time. Okay, there will be a greater amount of current. Have you all used this application called PHET? P-H-E-T. Have you all seen that before? Okay, it's actually this one. Let me just show you. It's pretty fun. You can actually practice setting up your own circuit. Okay, have you seen this before? Can see my screen, huh? So this is the application. Okay, if you are interested, PHET, you just have to Google PHET. You will go to this website. Okay, and then you can select the circuit construction kit. What happens is if I close the circuit here, all right, I can see the current flowing, but this is actually conventional current. If you were to look at electrons, okay, we talk about, yeah, you all must have used it before. Okay. So if you talk about electron flow, in primary school, your teacher don't ask you to even look at the electron flow or how current flows. You just need to know current flows in a closed circuit. But now in secondary school, you must know how it flows. It's flowing because the current is generated because the electrons are flowing. And this is how electrons flow. And you must know where it flows out from. Take a look here. If you look at the battery, okay, now in secondary school, you call it the dry cell. It will come out from the backside, the negative terminal. Okay, if you are going to indicate that the electrons flow from the positive terminal out, okay, you'll be marked wrong. So this is crucial, right? And then when you talk about the voltage, let's say I want to measure this voltage of the battery, you connect it this way, and you can see that, okay, this battery is actually a 9-volt battery. Clear? So if you remember using this before, good for you. If you don't remember, you can start playing with it after the class. Otherwise, 1.5 hours, you'll be trying to play with this thing. I can send you the link. Okay, I can send you the link. Then you can have it and you try it after the class better lah. Because if you do it now, okay, and I know some of you already went to this application already. Okay. If you do it now, then our lesson could be slightly affected. Okay. So just now I showed you how the charges are flowing. Remember, usually it's the electrons flowing only. So we just refer to electrons moving in the circuit. Okay, that is the charges. Okay. So mathematically, how do you calculate the charge? Okay, you use this particular formula. I have not seen it being asked in Sec 2 exam yet. Okay, to ask you to calculate these charges. Okay, but it's good to know. Okay, this is actually the formula to calculate charge. All right. So just now I showed you using PHET, right? Conventional current versus electron flow. So current will flow in this manner from the positive terminal outwards, okay? And then close the circuit, it will go back via the negative terminal. But that's not how electrons actually flow, okay? So this is conventional current. All right, and this is electron flow. Look at how electrons are moving. It's always from the negative terminal out, because electrons are negative. Okay, they are negatively charged. All right, and then it flows back to the positive terminal. So far, okay? Still okay, right? Harini went missing suddenly. Disconnected. All right, so electric cell, I mentioned earlier, you will see a lot of the exams, even the worksheets in school. Okay, you don't talk about battery like you did in primary school. We will call each of this a dry cell. Okay, wait 1 minute. I let Harini in first. Okay. So each of this is known as one piece of dry cell. Okay, if you have only one dry cell in your circuit, that is your battery. If let's say your circuit, okay, consists of maybe 3 of them, this collectively is still known as your battery. Understand? So the battery is actually the electrical source. So it's really dependent on how many dry cells are in it, then it will determine how strong your battery can be. Okay, one dry cell is called a battery. 3 dry cells connected together is still one battery in the circuit. You read about this also, right, Haresh? Yeah, so usually they might even ask how many dry cells make up the battery in the circuit, something like that. Yeah, you read about this already, about the battery and the dry cells. Those are different. So you have to really forget about what you have learned in primary school. Don't say that there are 4 or 3 batteries here. No, this is one battery made up of how many dry cells? You have to count. Okay. So the electrons carry electrical energy to this light bulb. So electrical energy is converted here at the light bulb, right, to another form of energy. What is the main form of energy here for light bulb? Light energy. So other than light energy, what else would you expect for the light bulb? So when the electrical energy flows through it, right, it's being converted, okay, to one main form, which is light energy. There is also another form of energy is converted to. What do you think that is? Yes, Anaki, heat energy. That's correct. Okay, good. So far, so good. Still okay? Can be a little bit drier, the lesson. Okay, then the electrons will then return back to the electric cell. Okay, electric cell is also the dry cell. Okay, this is actually just a recall. Most of the symbols here you should be familiar, like the light bulb, okay, and then the wire, the switch, okay, the electric cell, or you call it the battery. Now, when you see the dashed line here, okay, when you see the dashed line here, it represents that you don't know how many batteries are there. They are okay, I cannot say battery, see, bad habit. Okay, it actually represents a number of dry cells, okay, making up that battery. So if you don't know how many there are, supposedly quite many, you just need to represent with dotted line. If it's something like 3 pieces that you know, or let's say it's just 2 or 1, then you can draw accordingly. So one dry cell is represented this way, okay? Positive terminal is a longer line. Negative terminal is a shorter one. Do you need to show that the negative terminal is fatter also? Is it necessary? No need. That's right. You don't have to draw such that the negative terminal is a fatter line. No need. Just shorter will do. Okay. I have also seen diagrams like this. So what does this tell you? Anyone?
2 dry cells.